Welcome to USD with Solaris Asset Building. This course will take viewers through the process of building USD assets according to the ASWF USD Working Group guidelines. Some of the topics covered in this course are understanding and creating variants, going step by step through the asset structure guidelines, learning how to use the component builder, and working through a practical example of setting up a small scene. The goal for this course is to understand the specifics of USD assets and how to properly set their hierarchies for your specific needs. Variants are an important concept when talking about USD assets, and we'll begin this course with a high-level conversation about what they are and some of their common uses. So what is the concept of a variant? Well, speaking kind of from a high-level view, they're a way to store versions of child primitives on their parents, right? So if we wanted to do something with these child primitives, and we've talked about the concept of a primitive before as being pretty much anything in the USD software. Well, say we wanted to save some different variations of that on a parent, well, we can actually do that through these variants. So specifically, what are USD variants? Well, a variant set contains individual variants from which a user or process can choose. So that basically means that these parent primitives that we're storing these different variants on, we can go in and choose which one of those are being displayed and kind of composed in our scene. The next thing to realize is that variants are really flexible with the things that they can store, right? So we can store, materials, shaders, geometries, or we can change even the hierarchy of these child primitives. So there's a lot that we can do with them, and it's not really prescriptive in the ways that we have to do it. They're very flexible, just like the rest of the USD software is. It's a very flexible idea that we're able to kind of use to whatever means we need. So another thing that we should keep in mind is that these variant sets that contain our variants should be stored on the root primitive of our asset. So that just means that basically the top level of a component that we're saving to disk, that's where we should save our variant set, so that if something like our primitives are marked as instanceable, or maybe a payload is unloaded, we're able to actually still change what variant we're looking at. So that'll be a really important concept, and we'll see a little bit more of that as this course goes on. And another thing to keep in mind is that they don't change the namespace all the way down to the primitive that owns the variant set. And that might be a little bit wordy, but I'll try to explain this with a really practical example here. So let's just say that we have a bunch of different trees that are stored here in this path. So we have geo, forest, tree, model. That's our path. That's kind of our hierarchy, right? And let's just say there's a lot of different tree variants that we can select on that tree primitive, right? Well, that tree primitive can change the model primitive, but it can't change forest or geo. It can't change that namespace above it. That's not how it works. So it can only change the namespace after the primitive that owns that variant set. So that's something really important to keep in mind. We can't change the kind of upstream hierarchy, the parent hierarchy. We can only change the child hierarchy. So let's talk about some uses for variants and what we could kind of think about ways that we could use these. So one thing that's obviously the most common use for this is families of geometry, right? So we just talked about our tree example, right? So in this example, we could do maybe a primitive that switches between different types of trees. You could create a tree variant set with like 10 different models of trees, all different types, colors, seasons, things like that. That could be a really great use in this example, right? Is seasons of trees. That would be an easy thing to kind of change maybe even globally across all of your different primitives and stuff, set the season that way. And it allows users downstream of these creations of these assets to be able to tweak the selected geometry, right? It doesn't bake that into the scene inherently. It actually gives you the flexibility to kind of change that as needed. Another thing that you could possibly use variants for is levels of detail. So different LODs in your scene, right, for geometry and things like that. So if you had something way in the background, you could set a level of detail in a variant that would drop it way down so that it's getting just a really low poly version of it. So you don't have to use up resources in order to visualize those things. And then finally, material assignments is a really common thing to do as well. We could set kind of one global material assignment for a variant. We could also go in and specifically describe how to set different sections of the geometry, subsets of it, two different materials. So that's a possibility as well, and something that's a very common thing to do with materials, assigning them to different variants. So hopefully this gives you some context of how variants are used and starts you thinking about what we're going to be able to do with variants as we move forward through this course. Let's first talk about the Create LOD LOP. This node can take our incoming geometry and make multiple LOD variants from it. From here, we can start the conversation of how variants appear in Solaris and how they appear in the actual USD code. All right, so I've opened up the HIP file for this course, and we're going to be in the Create LOD section for this chapter. The first node here is going to be referencing a basic pig.usd file from disk. However, you won't have that to start, so I just created a little spot up here that we can use to write out this basic pig. So we'll just save that to disk, and there's just a real simple SOP network in here, add some path attributes and things like that, just to give us kind of a starting point to work with here. All right, so let's come down to the Create LOD LOP. So the first thing we're going to do is set our primitive path. In this case, we just have this one hierarchy in our scene, so we'll take the top of that and just say base pig with LODs as our primitive path. The next thing we're going to set is the variant set that we need to create here. So what the name of that is going to be levels. We could put anything we wanted to in here. I just shortened level of detail to levels. And each variant is going to get their own name as well. So here we are going to give it the kind of the prefix of LOD underscore, and then it's going to have an ID set after it. In this case, it's going to start at LOD1 and go up to 4. We could change this offset here to -1, and sure enough, we'll go back to 0. So 0 would be our base. So depending on what you need it to be, we can change that. Here you can see as well that we can obviously set the display of which variant we're looking at, and we'll talk about that in a second. So down here we can see we have a number of LODs that we can set. This is arbitrary. We could set 2, 3, 4, however many you would need. And there's a few choices that we can make for each of our LODs. So the first thing is the keep percent. So just basically what percentage of the incoming geometry are we going to keep? If you've messed around with the poly reduce node at all, this is going to be very similar to how that works. This is kind of just a high level version of that. It's buried inside of this this HDA that was created here. So so basically, what percentage of the incoming do you want to keep, and do you want to preserve the quads or allow it to be triangulated? And stiffening the boundaries basically just says if there's unshared edges, do we want to stiffen those or not? So in this case, we've got the first one is just 100%. The second one is going to be 50% and preserve the quads. The third will be at 20% and allow it to triangulate. And then the last one will be at 5% and also triangulated. So we can go through and take a look at these by selecting this display variant here. So we can do 1, this is the root. 2 is going to be a little bit less, and so on and so forth. And you can see here we have a really triangulated version here that we could use for just really low polygon count if we had a whole bunch of these out in our scene, right? So let's take a look at what this is actually doing in Solaris. Like we're setting these attributes, but where are they going? So if we open up our scene graph details and look at this top level primitive here, and look at the metadata, we can see that we have this variant levels. And this right here is just basically taking the name and appending it to this name just variant. So this is variant levels. If we called it variant geo, it would be variant geo, right? So each of these, this section here will take the name that we give our variant set. So anyway, so now we can see that we have LOD4 is kind of outside of this array right here, and we have LOD1, 2, 3, and 4 inside of it. If we turn this off, that is going to now basically not declare any variant that we're looking at, right? So in this case, we have all the variants, but we're not saying specifically to use one of those. So in this case, it's just defaulting to the first one. So we can set that, and as we change these, it's going to say outside of the brackets which one we are currently kind of viewing. There's another way that we could do this, and this could happen anywhere down the line. We could use a set variant here to kind of see what is happening inside of there, or to be able to specifically set a group of primitives to a specific variant. So in this case, we can say what primitive we're looking at. In this case, we'll be not looking at the geo, but we'll just be looking at the root here. The variant set is levels, and then we can look at the different variant names. Same concept here, where outside of these brackets, we're going to see the name that we're looking at. So we'll just set it back to LOD1. And that is basically how you can see what your variants are in Solaris. You can click on the primitive that's holding the variants, and then you can see it right here under the metadata. So let's write this out to disk, and we'll take a look at how this looks in the USD itself. So here is the actual USD code that we're using. We get the standard kind of header data up here, just some basic parameters of how the scene is set up. Here we can see that we're referencing in that geo that I mentioned. We're creating this variant sets right here called levels. And then now we're going to define the variant set, right? So here we have variant set levels, and each of these LODs are going to hold all of the information that specific variant is going to kind of describe, right? So here's the first one. This is the LOD1. We can collapse this and then kind of look at the rest of them from here, right? So we could say there's LOD1, here's LOD2. So we can collapse that, right? And so each of these are going to be holding the information from those specific LODs, right? So really kind of at a high level, we have the variant set levels, and then we describe each of these LOD 1, 2, 3, and 4, right? So the one negative thing to how this is being done here is that we're actually writing all of the information of that geometry into the variant, right? So this kind of is if you followed along with the kind of previous chapters in this learning path, these are going to be, all this data is just explicitly written here. It's not really referencing it from somewhere else. So this really isn't a very USD way of working, right? This is kind of baking all this information in. So in the next chapter, we're going to take a look at how we could actually reference geometry in as we're kind of creating our own variant set instead of writing it explicitly like we are here. We can use variants in order to give artists the ability to select from a set of options. There are two main types of variants that can be created: geometry and material. In this chapter, we'll look at an example of each of those. Okay, so we are in the variant setup of our example file, and here we're first going to work with geometry variants. In this case, we have 3 different SOP creates that are each creating a different kind of level of detail of our pig geometry. Nothing too exciting happening inside, just kind of setting up some color and making sure they're kind of positioned in the same place, and they're varying densities of geometry. So what we're going to do is we're going to bring all 3 of these SOP creates into this add variant node here. And this second input here, this kind of multi-input, is what we're going to use to kind of input each of these variant geometries. The first input is just the stage. Now, we don't have anything that we are using to for the rest of our stage. Our stage is empty at this point. So each of these variants are going to be the only things on this primitive. One thing of interest here that we should see is that there are there's a primitive path that we have set up here. So in this case, it's variant / $OS. So you can see here we're making a variant primitive up at the very top level here. Then there's pig LOD0 and mesh 0 that are going down in order. So here we have pig LOD1. So each of these are in this variant primitive. So that is going to be helpful because we're going to be able to say each of our variant source primitives are going to be coming in as /variant. So everything that primitive is going to be kind of our starting point, and then everything below that is going to be what we create our variants from. So that's one thing that we should note first of all. The next thing that we should note here is that this add variant node is actually going to be creating the primitive path for where these variants are going to live. So in this case, we can see that $OS is our primitive path here. And so that's going to set pig LOD variants as the name of this primitive. So there's our primitive that's going to hold all of our variants. And we're going to turn this into a component since this will hold all of our variants. We want it to be a component. And we're going to call the variant set levels just because we're doing LODs. Figured we'd call it levels. And the variant name default is just going to be the input coming in here, right? So each of these are going to get the name of the geometry coming into these streams. So at this point, we now have created a really simple asset with 3 variants. Now this is not a complex thing by any means, but kind of the beautiful thing here is that if we now were to come over to our scene graph tree and look at our variants, we could see here that we have levels pig LOD2 that is set right now. So obviously, we'd want to write this out to disk, so we can come down here and we can save this to disk, and we'll take a look at that in a second. But let's visually make sure that things are working the way we want them to. So let's inspect our variants. And here you can see as I selected this, it changed because the variant that we're looking for is pig LOD 0. So here we can set our variant set that we're looking for and the primitives that we should be looking for that variant set on. And then we can just change our variant here. So we can change to all of these different LODs. So in this case, it's certainly working. We have exactly what we want. And it's a really simple way to set up geometry variants on a primitive. So let's just look through the actual code of our USD file that we wrote to disk. So what we did here is that we have a variant set here that we're working with. Here we're creating the variant set levels. And in this case, we're kind of giving it a default starting option here. So the levels string is set to pig LOD2 by default. So this is just setting our default variants here. So this is where the variants are started to be created on our pig LOD variants primitive right there. And you can see here we've set that to a component. So each of these levels in our variant set, pig LOD 0, 1, and 2, are all reading in a payload that is basically just saying this file on disk right here, which is geo/pig LOD 0. And so these are just geometry files that we've created on disk. There's nothing overly exciting going on there. It's just the geometry saved to disk as a USD, but that way it makes this a little bit neater. And if we wanted to change out one of those variants, we could change out pig LOD 0, 1, or 2, and that change would propagate through our USD. So the next thing that we're going to look at is the material variants creation. So we're going to do this a little bit differently because we're going to start actually with geometry and then we're going to set the variants from there. So what we're starting with is just this basic pig geometry that we had written out previously. This is just basic pig.usd. So we're reading that in as a reference, pretty straightforward, nothing to talk about really there. And then this is where most of the work is going to happen inside of this variant block. Now you can see previously we did not have that variant block. And the reason for that is because we didn't have anything on our stage that was starting here. So obviously, if we're bringing in something that we want to add these shaders onto, we need to bring that geometry in to make that reference. However, we use this variant block begin to perform a layer break here. So this is kind of like a for loop that you might experience in regular SOPs or even in Solaris. But in this case, we're just adding a layer break on the top there. And this is going to be our kind of variant block, like our loop that we're going to work with. Now, it's not going to loop over the geometry per se, but it's kind of creating an environment where we can just save out these different variants to disk without having that upstream data written out. So what I've done over here is I've created a material library, just has a couple different shaders in it, gold, silver, and a green transparent, just to give some visual difference. And I'm configuring this layer here to just be saved as material.usdc, just so that it's saved to disk. Those three shaders are saved there. And then we can go and bring those in as references. So that's what we do here in this next step. Each of these references is bringing in one of those. So it's bringing in a gold material and putting it into this primitive path, basic pig with variants, material gold. So we can see here we have our basic pig with variants, and that was set up here as well. We have our source name with variants. So basic pig is our source name, and then I just appended with variants to the end of that. So a reference is bringing that in. If we open this up, we can see that the material is gold right there. And this next one is just going to be an assigned material, and it's going to assign it to be gold. And the next ones are just going to go down that same path. We're going to do the same thing with silver. Here's the silver shader, and this one's going to reference in the green transparent. And then we have this transparent color. Now the green doesn't show up in the viewport, but you can see here when I turn Karma on that it does have a green tint to it. So in the GL shader, it's not showing up there, but that is actually in the shader itself. So what we do is we bring each and every one of those into this variant block end here. And so we have the primitive path that we want to write these to. We're actually going to be adding this to its own, to an already existing primitive on the stage. So we don't need to worry about having each of these in some sort of source primitive that we're going to read from. What we're going to do here is we have our options block. That's this up here that's been created. The variant set that we're going to create is material. And And then everything else is basically pretty straightforward. The only thing I'm not going to do is I'm not going to set a variant selection. So by default, this won't have a shader assigned. So if we come down here, we're just going to write pig shader variants. I'm just going to save that to disk, but let's check our variants out here. So we can see that the gold, we can pull that up. We can pull up the green transparent, and we can pull up the silver. So those are all working just fine. So we have all of those saved onto one primitive, changes out the shader that's here and assigns it to the material. So each of these is working basically the way we want it to. So let's now take a look and see how that's being done in the USD file itself. All right, so we have a relatively kind of short file here as well. Not a whole lot going on. There's really more returns and things like that than there is actual text. But what we're doing here is basically the same. We're defining our primitive here, which is basic pig with variants. We're bringing that reference in off of disk, which is just basic pig. And then we're going to make a variant set material. Now, there's nothing else here under this variant set because we're not setting a variant by default. So there is no default material being set. So here's our variant set material, and we set up the gold, the green transparent, and the silver here. So we have these different shaders, these different variants that we're going to be defining. So then underneath that, we have a scope that we're creating, and then we're going to define this gold shader right here. And this is going to basically just bring in the reference off of the disk right here, the basic pig material.usdc. And within that, we're going to be looking for materials/gold. So this is going to bring in that gold. And then it's going to set the material binding right here, where it's going to bring in this prim path right here, and then set the material binding that way. So that's going to set that over top of Geo, and it's basically just going to make an override on that and add that material assignment. And it's going to do the same thing for each and every one of these shaders. So again, it's a pretty straightforward file that's being written out at the very end of this chain here. But really this setting up these variant sets and their individual variants that are within them is really just the idea that really is the power, because we can go and switch those whenever we need to. So in the coming parts of this course, you're going to see different ways that we're working with variants and creating more and more ways to kind of give that artistic freedom down the line after these assets are created. We can easily create camera-dependent LODs by using the auto-select LOD LOP. However, this is a feature that is supported in Solaris and is not inherently a part of the USD code. In this chapter, we'll take a look at why. Okay, so we're in the distance-based LOD section of our example file. And first what we're going to do is sublayer in the colored pig LODs that we had from the previous chapter. You can see here we have the pig geometry loaded. We've got our variant set, and it's set to pig LOD 2. So that's kind of step one for this. Next, we're going to just use an instancer, make a bunch of instances of these pigs onto the stage. There are about, I think about 300 here, if I'm not, 225, sorry, variants here that we're going to be working with. It's just a simple grid inside of the instancer, and each of these primitives with their variants are getting instanced onto those. You can see we're making these as instanceable references. Each instance has its own reference here. And those are all going to be what we set. That's the variants that we're going to set on each of those instances. We're just using the prototype primitive pig LOD variants, which is what comes in here. And that'll be our prototype for this. And it's coming into the second input. And yeah, that should be pretty much it for that. We're also going to be setting a camera up. So that should be in our scene as well, which is right there. There's a green camera right there. Might be a little tiny, but it's in the scene there. And so then what we're going to do, let's look through our camera here and go to our auto select LOD. And what this is going to do is, using these threshold distances here, set up which LOD we're looking at of our pigs here. I'm also going to lock the camera to the view. And then as I tumble around, you'll see that this gets updated as the camera moves around. So we're able to set up the pigs to be higher resolution closer, kind of this middle resolution in the midground, and then in the far distance we have really low resolution pig heads. So that is the auto select LOD lop working right there. Basically, we set up our primitives, we set up our camera, give it the variance set we want, and then set these different threshold distances in order to set those. So the thing to know here is that this is being done not as a part of USD, but it's something in Solaris that we were kind of using we're using the USD to drive these LODs, but it's not an inherent part of the actual USD software itself to be able to set variance based on distance. That's something that's happening in Solaris, just using USD underneath it. So let's just write this out to a file so that we can see exactly what's going on here. We're just going to make an output file, save that to disk, and let's open that up and take a look at what's specifically going on in there. Okay, so this is our code for the USD file that we wrote out. We can see just some pretty standard things happening here. We're creating a transform that's going to be called instance pigs to grid. That's going to be a group. There's also going to be a scope prototypes. That's going to be a group that's going to hold the prototypes that we're going to be using for our instancing. This is the pig LOD variance that we brought in from disk. And here we're setting it to pig LOD2 as kind of a default. And then here's the variance set that we're using called levels. And then each of these variance sets here, pig LOD 0, 1, 2, are all part of levels. And that way we can basically say that depending on which one of these variants, we're going to load these different USD files from disk. So that's just the standard prototype information there that we're working with. Then we come down here and we start to see that we're going to define our different instances here. And so here we can see instance 0. This is an instanceable primitive. We can see the reference that we're looking at here, and then the variant that we're setting. The only extra stuff that comes with each of these instances is just a couple alternate things here, like number of, which is basically the number of variants, and the distance here, which is the distance from the camera to this instance position. However, there's nothing in here that really tells us what to do beyond that. It's not recalculating that distance if that camera was to be animated, for example. If we brought this into another piece of software, it's not going to be able to recalculate that distance because there's nothing in this code that inherently says that. So each of these are kind of their own standalone element that has a couple extra primvars that are set here, but nothing really that's telling it what to do beyond that. And you can see here as I scroll down, there's all of the instances here kind of on this in this column here, but there's nothing beyond that we're going to be seeing. And if I scroll all the way to the bottom here, there is a little bit more code that you'll see. This is just the camera, but again, there's not anything here that's inherently going to be telling it this is how you recalculate this, or any type of code that's going to allow us to do that. So this is one of those examples where something is kind of built in Houdini using stuff that isn't in USD to translate different USD primitives. So this is not something, hopefully, that you can, hopefully you'll understand that this isn't something that you can just do in any other DCC program that might be out there. This is something that's strictly in Houdini, and you specifically need to have that auto select LOD down on the stage in order for this to work. So one last thing that I'd like to bring up here is that if you were to change this from render current frame to render specific frame range here, and had it go through all 240 frames and animated your camera, you would not be able to actually save the changing variance to disk. USD doesn't inherently support having a time sampled variant, being adjusted on a frame by frame basis. So that is something that you could only do by doing something like flushing your data after each frame and adding a $, F3 into your output file. Now, in this case, we'll have all of our USD saved on a separate file for each frame. And as we've learned in previous courses in this learning path, that's really not the way that you want to do this. It would create a suboptimal performance hit on your scene being composed, because in essence, every single frame it has to recompose the entire scene. So you get really, really bad playback performance with that. So unfortunately, there's not really a great way to use this with animated cameras. And it's just something that we want to note and just make sure that you don't try to go down that path and then, become frustrated. So as of right now, that is the limitation currently here in USD and Solaris. This chapter will introduce you to the ASWF Asset Structure Guidelines. While USD is extremely flexible in how you build your scenes, this document will introduce us to some best practices. During the rest of this course, we will be conforming our work to these specs. Here is the link to the asset structuring guidelines on the ASWF USD Working Group GitHub. This is a really, really big document. We're not going to be going through the whole thing right now, but we're going to go through some of the common examples that you're going to find. And if you want some more information about edge cases or things maybe that are a bit more in-depth than what we have time to cover in this course, please check out this link. It's a really, really great read, and I highly recommend it. So let's just recap a little bit of terminology. Hopefully this is going to be mostly review for you, but just to make sure we're all on the same page. So assets are called models in USD. That's one thing to keep in mind. The component models are these publishable assets, and they keep their geometry behind a payload, which means that they can be loaded or unloaded in the viewport. So that's a really helpful thing if you've got really complex scenes or a lot of geometry in your models. Now, assembly models are going to be publishable assets, but they reference other components or other assemblies. So an assembly is a way to basically think of multiple pieces being brought together into one, multiple components being brought together into one thing that you're going to publish to disk. And another thing just to keep in mind that is you should publish component and assembly models, and they should inherit from a class primitive. That's going to become a little bit more clear in the coming parts to this course, but just know that there should be this class primitive, and our models are going to inherit from that. That's an important thing to kind of keep in mind. That allows you to do to update your geometry downstream very easily once you create it, and maybe even populate a whole scene with it. Gives you kind of a place to be able to make quick adjustments to your models. So first, let's just talk about the most simple component structure that we're going to make here. So obviously, like we said, this is the most kind of basic asset published in a USD pipeline, is these components. The component kind is always on the root of your primitive. You can see that right here in our scene graph hierarchy that I've got kind of laid out here. So if we were making something like a book, it would be a transform, and it kind would be component. So that would be kind of the root of our model, and that's going to be where we put the component kind. We also are going to have a payload inside of there. That's not going to be noticeable in the scene graph hierarchy, but when we look at the file structure, we can see that our book USD is going to be maybe the top level file. Then that is going to load this payload.usdc. And that is going to allow us to load and unload our geometry based on if we need to see it in our scene. Another thing to note is, like I said before, these are self-contained and portable. We're not referencing external geometry models, anything like that. This is all saved in one spot on disk, so you can then move it around and be able to transfer these files relatively easily. And again, there is a class primitive that we're going to be inheriting from. And basically that means that if you look here in our scene graph hierarchy, we have our class here. This is our class primitive. And then there's a book primitive underneath that, and that is inherited by this component. So this component here is looking at this class to see, hey, is there anything that we need to update within this class book namespace in our scene graph? And if there is, then it'll adjust that and adjust every book in our scene that is referencing or is inheriting from that primitive. So just something to keep in mind with how kind of the scene graph hierarchy is set up here. We also have this geo and material. That's pretty straightforward. That's going to be where our geometry and our materials are going to go. And those are going to be saved on disk as their own files, kind of at the very base level of this kind of hierarchy of files. So that's just a simple component that we're going to, if we're building something like that, this is pretty much the simplest way that we can set up our USD to work. now let's talk about using purpose scopes. So this is kind of taking that same hierarchy and moving just kind of one step further with it. And what this does is adds in a further proxy and render scope under our geometry. And the nice thing about this is that this allows us to have, low quality and high quality geometry that we can easily switch in the viewport. One thing to note here is that there is no need to mark every primitive with its purpose. Just the parent scope is sufficient. So if you have a bunch of stuff under your proxy geometry and a bunch of stuff under your render, geometry, that does not need to be, those all don't need to have their set purposes as proxy or render. Just the parent primitive will suffice in that case. And organizing our class primitives isn't necessary. We can just leave the class as a book. With just class and book underneath it. That's a fine way to work. However, if you did want to specify other hierarchies within there, it certainly could be something that makes it easier for you. That's kind of up to you, but it's not a necessity. It will find the primitives that are underneath, regardless of how you set up the hierarchy of the class primitives themselves. So just something to keep in mind as well as you're building simple components. All right, so those are kind of the basic components, but what about assemblies? How do those look? Again, just as a reminder, an assembly is an asset that kind of brings together other components or assemblies from disk. So in this case, maybe we'd be making something like a bookshelf. We can see here in our scene graph hierarchy, we have our bookshelf. This is set, the kind is set to assembly. Maybe on that bookshelf is going to be some books, and that's going to be a group. And then down here, you can see we have book components, 5 of them that'll be loaded maybe throughout the shelf, however that might be. And then maybe we have another decoration here. That's a decoration component down here. So that's its own separate component as well. So you can see here that we have a bunch of components that we've brought in into our assembly that are going to be coming off disk and kind of arranged on this bookshelf. And then this entire this entire scene graph is going to be saved to disk as an assembly, USD. One thing to keep in mind too is that when you have these intermediate kind of primitive that are just there to help organize, those can just use the group kind. You don't have to have those set to anything else like assembly or whatever. That can just be a group X form. And then the payload arcs don't really need to be set within this assembly here because they exist usually within your components, or at least they should. And so in this case, if you were to unload your payloads, that's going to unload all those components already. So there's no reason to add more payload arcs in here. There's no reason to. We can simply have these components, their inbuilt payloads work for us, and we don't have to add more. And that'll actually could if we did try to build payloads into this assembly, that could actually add some additional calculation overhead that won't be preferable. So then if we were to take that maybe even a step further and talk about what if we added materials and geometry to something like our bookshelf here. It's basically the same exact setup, but instead we have our own new geo and material scopes that are added in our scene graph hierarchy here. So in this case, when our new geometry is brought in, we do want to actually add a payload because these don't have payloads set up on them. So this is new geometry that's going to be a component in and of itself. And so we want to make sure that it has a component kind and also is set with a payload internally. Now, obviously, we haven't talked about maybe some of the best ways to do that, where we're payloading and doing all that kind of stuff. That will come in the next few chapters, and we're going to really dive into how those are specifically set up. But just something to keep in mind that if you're adding in geometry to an assembly, make sure that that is behind a payload as well. And then the last thing to talk about from this document is variant layers. So with this, if we're setting up separate variants, we can store those as separate files, or they can be stored in the main root layer of the file. So for example, if we were setting up, say, a book with a bunch of different covers or something like that, which we will be doing in this course, you might want to set it just so that the variant is set on the root primitive, maybe book, whatever is the top primitive, and all of your variants will live there. Now, the nice thing about that is it's going to simplify file management, and it's going to reduce the number of layers that USD has to track. However, you can actually save out separate files for that kind of specify each of the variants that are created in that component. So maybe you have 5 books that are made in this one asset. Well, you can save out 5 additional USD files that would actually each reference in one of those variants and would still give you access to all of the other variants in the file, while specifically saying that this is going to, by default, load one variant for each of these files. We'll see that in a little bit more detail later in the course, but this is certainly something that it can be really powerful. It could be easier for tools or pipelines. And one example is the layout lop in Solaris. That's one node that really likes having separate files for each of the variant layers. So just something to keep in mind as you're starting to think about building assets. These are all parts of the the asset structure guidelines. Like I said, there's a lot more that's in there, but just keep these kind of base things in mind as we're going through and creating these assets. And then you can always jump in there and find more and more detail about maybe certain edge cases that you might come across. Let's begin the process of setting up a USD asset based on the guidelines we went through in the last chapter. First, we will set up our geometry with the proper hierarchy and with our proxy and render purposes. All right, so let's take a look at the recommended asset structure section of our demo file here. And I've broken this up into a few different sections. I'm just going to zoom out here for a second so you can see. We have kind of color-coded sections here that'll guide us through each kind of part of this setup. So each of these will be chapters within this kind of overarching idea of the recommended asset structure. So here, we're going to just start off by putting down a primitive node. It's going to be creating the path high-res pig. It'll be a component kind, because if we remember, our top level primitive should be a component when we're talking about an asset. And from there, there's not really a whole lot we're going to do. That's just kind of creating our primitive path there. The next thing we can come down is look at this primitive node here, and this is going to create a couple more hierarchies for us. Now, we don't want these to be components, so instead I've separated them out. I've turned the primitive kind to none, and we've set both the parent and the primitive type to scope. So we can see here that we're creating a whole bunch of scope primitives here. They're in the hierarchy that we need, and I'm just going to turn on a couple other things here just so we can kind of take a look at all these different options that we'll need in a second here. So there we go. We'll just kind of sort this a little bit. Great. So there we have our hierarchy. We have our geometry, proxy, render, and then also for Houdini, a sim proxy can be really helpful for if we're doing things like collision detections and things like that for tools in LOPs. So that's kind of our beginning setup for our hierarchy that we're going to put our different elements into. So here I've created a high-res pig. This is pretty straightforward. We've got a pig head geometry, add some normals. We're removing the groups here because we don't really need those per se, so we're just going to get rid of those. And then I'm just going to move it to the floor. Each of these separate pieces of, separate parts of our network here are going to be set up with a path on them. So for this first one, we're going to subdivide it to make it a little bit higher resolution. And then we're going to add a path attribute and put in the hierarchy that we want this to go to. So we can see that this is going to go to high-res pig, geo, render, and then it'll be pighead will be the name of the geometry. So this one here will go under the render primitive and it'll be called pighead. So that should be good. The next proxy path here is just has a poly reduce, and then we set the proxy pighead. So that's going to go under the proxy primitive. And then this last one is just going to shrink wrap it, do a quick remesh, and then set that to go under the sim proxy path. So then we merge those all together. So all those geometries are coming out at the same, in the same stream. And then we have those, just a null here that we can use to say go to lops. There's some examples or some information here if you want to read a little bit more. And then what we're going to use is a SOP import. So I'm going to come over here, highlight this. And what we're going to do in this case is we are only going to define the leaf primitives here. So I've checked this on and made sure that this is checked as well. The other thing I did was copy the contents into an editable layer just so it's kind of in the layer that we're working with right now. If you remember, we have our scene graph layers, and these will create, a layer that's going to be working on just that geometry basically. So we'll eventually flatten all that down into one layer at the end, but right now we just have a working layer that we're kind of using here. So there's not a whole lot else that's really going on in here. We're just setting our SOP path here that's going to be pointing to that SOP network that we're importing the geometry from. So now we have pig heads. We have 3 of them here. Each of our different geometries have been brought in. However, we need to make sure that these are all set properly, right? Right now, they just have a default purpose set to all of them. And we want to make sure that those purposes are set properly. So let's do that. So here we're going to start setting some of our geometry purposes here. So this is going to be our high-res pig /geo. We're going to set that to default just to make sure that that is properly just kind of initialized. Then we have our proxy purpose that we're going to set. This is going to set it on the high-res pig geo proxy. So that's going to be just this proxy primitive right here that's getting the proxy purpose. You can see here we have this checked and it's adding the purpose in. Nothing else really happening in these parameters. Then we come down and we're going to set the render purpose. Now it's important to set the proxy purpose first because in the next step here, we're going to actually define what our proxy primitive is. So here we're working on just the high-res pig /geo/render. So it's this primitive here. And we're setting the purpose to render. And we're also setting what the proxy primitive for this is going to be, which here we can see it's going to be the high-res pig geo proxy. So that's our proxy primitive. In fact, if we slide this over just a little bit here, we can see that those are in fact being set as the proxy path. Okay, so now at this point we have our proxy and render purpose set. So let's also set our sim proxy purpose. This is going to set it to a guide, and it's also going to set the visibility to invisible because we don't want to really see that in our scene at all. We're just going to set it invisible, and we're doing this on the sim proxy primitive right here. Now we should also mention that you don't have to set the purpose on each and every primitive that's in this scene graph tree. You can just set it to the top level scope primitives, and that will also flow down into its children primitives as well. So something to keep in mind there. And then we can come down here and we can just make sure that we have a sim proxy set. The way that we do this is by going into our edit properties here, and we basically set the sim proxy control and the sim proxy here that we're going to use. The sim proxy control is just this, and then the sim proxy is a string that we added here. So we have those two basically set up there that will allow us to say what the sim proxy is going to be and what this does. So that sets a value on the primitive here that we have selected. We have high-res pigs selected, and this is going to set the sim proxy relationship right here. So now we have that set up there. We can see that that is set. So that's the reason that we're adding this property here, which is going to be placed onto the high-res pig primitive. And then this last one is just setting the extents. We're looking at everything under high-res pig, and then also adding in the subcomponent kinds plus anything inside of the geo. So this is basically just saying get all the primitives, get everything that's in the scene, and basically get the extents of it, create a bounding, create the bounding properties for that. And so that is just basically setting the extents for all of these different primitives and things in here. That'll be helpful for when we're setting our bounding box for our payload a little bit later. So now we're going to set our configure geo here. And the one thing you might notice is that we actually still see both of these, both of those geometries in the viewport, so we can just make sure that we can go back and forth now and set it between the preview and the final render. So that should be working just fine. So we have both of those geometries showing up. So that means that we have each of those set properly now. Sometimes you'll have a little glitch in the viewport for that. You might need to use your reset viewport from labs in order to clean that up. But so now we have our configure layer here. We're just going to set our save path, which is going to go into our HIP file. We're going to use the HIP name just in case there's other things, other lessons from this path in that same folder. And then assets, high-res pig, and geo. I'm saving these as USDA files. They should normally be USDC, but that's just so we can take a look at them and see what gets written out. And finally, the default primitive is high-res pig from that. So that just means that when you reference this in, you're just going to be referencing in from this position here. So let's just take a quick look at the actual code in our USD file just to see exactly what's getting written onto disk. Now, by default, you won't just be able to save this from that layer configure. You'll have to save to the bottom of the network. So if we go down to the bottom of our network here and save this USD to disk, click save to disk, that'll make sure that all the files get written out. You'll be a little ahead of where we are for the rest of this section, but it will give you the files. So let's just look at this USD here real quick. So we're just obviously making a high-res pig component. We've made that custom SIM proxy relationship here. So we have that SIM proxy, and then we just start defining some scopes like the geo. We've got our extents here, our render, and then this is the proxy primitive that's going to be linked to that. So we have the purpose render, and then down here again we have the extents and all of the actual geometry information. Then we come down, we can see our proxy scope with the purpose of proxy. Then we define pighead and have all of that geometry information within that. And then lastly, we're creating the scope sim proxy. Now this is actually up outside of the geometry scope that these are within. You can see here this has a geo scope, and they kind of live on that same exact level. So this is the sim proxy set to guide and invisible, and this is the pighead mesh for that section there. So pretty straightforward file, but good to just take a look at and see what's going on inside of here. So that is the geometry section of our recommended asset structure. And in the next section, we're going to start talking about how to set up our material. So that we'll take what we've made here and then continue down the line and add some shaders to this pighead. As we continue to walk through the asset guidelines, we'll now look at how to set up the USD materials. All right, so we are now continuing on into the material section of this asset guidelines portion of our network. You can see here that we're coming from the geometry configuration layer here that we've got set up, and we're going to just kind of branch off of this and add our material over here. And so what we're going to be doing here is, first of all, we're going to set up a layer break. Reason being, we don't want to have any of our geometry saved into this layer that we're setting up here. So we're making sure that there's a layer break so that we're going to be starting a new layer. Just as an example here, you can see that as we come down here, we're going to have our configured geo that's set to a save path, and it's above a layer break. But now we've created a new kind of implicitly non-setup layer that we're going to work in and then configure that to save as well. So that's what we're doing here with the layer break. The first section here, we're just creating a shader here. I have a channel set here using the create component prim path. So this is just going to look up to the very top level here, up here to create component, and it's just going to append material to the end of that. So it's going to make that path for us there. This is going to bring in the materials from inside of this network, and we're also going to be generating preview shaders, so that'll allow us to see them in the viewport. So here's our create shader. We're just going to jump in there and look at it real quick. It's just a green material, Material X standard surface. I have a green base color set up on it. Nothing really, crazy going on there. And that should be something just to kind of give us a little visual indication that the shader has been applied. So in the next step here, we're going to assign the shader. So where we're going to assign this to is the high-res pig geo. So we're applying it to this primitive right here. The reason being is that will apply to both our proxy and our render geometry. And in this case, we're applying just one shader to the whole to the whole object. Now, if we were doing something a bit more specific and technical, what you would usually have are subcomponents maybe underneath each of these meshes in order to assign shaders to specific parts of your mesh, right? So in this case, we don't have that, so we're just going to apply it all the way up here to our geo, and then that way we know it's going to kind of flow down all of those primitives and be applied to both the render and proxy purposes. And here's the material path that we're selecting. Again, we're just calling that green shader. It's under material. So right there it is, material green. There's our shader. And then the last piece of this network is going to be the configure material. And so we're going to set our save path here to pretty much what we had before, except just switching out material instead of geo. We're going to still keep the high-res pig as the default primitive for this layer that we're saving to disk. And then if we just scroll down here, we can just see that this is the setup that we're using here. We're not going to flatten the input. There's no need to. And we don't need to start a new layer because we're going to be using this kind of in a little bit of a different method when we come down here into the next step here. So pretty much that just stays as default and everything else should be fine. So what this is going to do then for us is save out a material file on disk that we can then use later on in building our asset in order to reference that into a payload layer and then have that payload referenced into our main asset file that we're going to have on disk. All right, let's take a quick look at this material file that we're saving to disk. So what we're doing here is just putting an override to high-res pig and then defining the scope material, defining the material green, setting up the outputs basically from our two shaders, our standard shader and our preview shader. And then we're starting to define them here. So we're defining the material X standard surface 1 with the ID here, and then setting things like base color, coat roughness, emission, things like that, all shader properties as we go through. Not a whole lot of importance here since we're basically making a really just a green shader. There's nothing really in depth going on there. However, when we get down to the bottom here, you can see that there is the US preview surface that's been created by our material library. We have that checkbox that we checked and it made sure that it made the preview surface. So that's something to take note of. And then finally down here, we're making an override on geo and we're setting this material binding relationship. We're setting geo to relating that to the high-res pig material green. That's where we're assigning it to. And here we can see high-res pig material green. So it's looking up this material and assigning it down here at the bottom to the geo primitive. So again, not a whole lot going on in this file, but just good to see what's being written onto disk as we kind of step through this process. In the next step, we're going to see how to set up that payload and kind of continue on building this component geometry. The next step in our process is to create a payload arc for our geo.usd and mtl.usd files. As we've learned previously, this is important to be able to unload our geometry in the viewport for better performance with large scenes. All right, so let's take a look at the payload section of our asset building workflow here. So what we're first going to do is set up our two streams that are coming in as references. So what we're going to do here is we're going to take the configure geo, configure layer node, and this configure layer node that configures our material. We're going to put them into the second kind of multi-input of this reference node here. And we are going to also create a new primitive, and I'm just using this as just kind of a blank primitive. We've already defined it a little bit earlier in our setup. This is basically just a component that is just doesn't have any type. It'll just be there as kind of a reference placeholder for when we compose things on top of it. So we're using that as our input stage to be able to reference these onto here. So what we're doing here in this reference is we've turned off the file and internal references. So I've cleared these out. There's no references coming there. And we're using the multi-input to create our references. So the primitive path that we're using is a channel from the create component prim path. So that's up at the top of our network. So it's getting that base primitive path from there. We're then editing existing primitives and we're referencing the inputs, right? So we're referencing these two inputs into our stage here. So into our one kind of blank primitive that we have on the stage. So nothing really looks like it changes here. The only thing we're seeing is this high-res pig turns green, and we can see that that means it has a composition arc, which means there's some composition happening here now, which means that USD is composing things together. So the place that we see this the most is in the scene graph layers. So here, I'm just going to expand this all the way. We can see that we have our root primitive here that we had created, and we're referencing now both our geo.usda and material.usda files into it. You can see here these are both being referenced, right? So that is what's happening at this stage right here. If I was to turn that off, nothing is there. Turn it on, and now those two are being referenced in. So that's looking good. It's bringing those two pieces of data off a disk, and referencing them there. And then the next thing we're going to do is configure this payload file. So here, we're going to do basically the same thing we did before. Save as in the high-res pig folder as payload.usda, and the default primitive again is going to just be looking up that channel reference to our prim path in the create component, which is just /high-res pig. We're not going to be doing any flattening here, starting a new layer, none of that. But this is just setting where this save path is. Now you can see that this file is going to be saved as payload.usda. So now we can see that these two files are being loaded into this file payload.usda. So now we want to take that payload file and create that payload arc onto the root primitive of our stage. So now this next reference here is going to be set similarly, but slightly different. So here we're going to also not have any file or internal references. We don't need that. We're going to use the multi-input again. We can see the primitive path here is set to high-res pig just like it was before. So it's going to be creating that, that composition on this high-res pig. But if we look now, it says it's a loaded payload. So now this is creating a payload that we can unload there. And it's using this wire up to this primitive here. So we're just using that same kind of empty primitive to do that composition onto. And now instead of referencing, we're payloading the inputs, right? So this is, exactly what we would want to have happen there. This should be pretty straightforward and understandable, hopefully. And then under our created primitives here, we're just going to make sure that they're set up to be component and the parent primitive type is none. So now we should be good. Let's take a look at what this does to our scene graph layers as well. We now have our geo.usda, material.usda being loaded into our payload.usda, and that is being payloaded to this top layer, which has not had a save path set yet, still is has an implicit save control on it. And we're going to use this layer for the rest of what we're going to be working through here with creating a couple more primitives here that we're going to use, and then ultimately just saving the root file for the asset. But we can see that once we do save it, it will be saved into this path here. So right now it's not set up, but that is where it's going. And then the very last step in this section is to loft the payload info. So what we're going to see here is that we're actually going to be lofting information from all of the primitives up to the very top level of this asset. So here, what we can look at this high-res pig and go to our scene graph details. I'm just going to slide this over a little bit here, give us a little more room. And just by toggling this on and off, we can see that there's a bunch of information that's being pulled from all of the primitives inside of this, hierarchy here up to our top level primitive, the high-res pig. You can see here the extents have been brought up. There's some draw modes, different things like that are being set here. And this just gives us that information when the payload is unloaded. So this is a really important step to be able to get that information up kind of to the top of our asset so that we can reference that information, whether it's the payload is loaded or unloaded. So that is the what we have to do in our network in order to set this up. Now let's go take a look at what the actual file looks like when we save that to disk. So here is our payload.usda file, which is relatively small and we can go through really quickly. But just something to note that this is really kind of just an intermediate file that exists on disk to just make sure that we can unload these other two files from disk. So here we have our high-res pig. It's a component. Here's our two references that we have. One is being material.usda, the other being geo.usda. And that is it. It just has two references inside of it that it's going to load up for us. And it's going to allow us to then cut off the payload from the rest of our asset, from the top level of our asset. So that's going to give us that ability to load and unload this specific file right here, because there is a payload arc from this to what will eventually be the top file layer of our asset. So just a really simple file here to take a look at, but good to know at least what's going on inside of there. And then in the next chapter, we're going to talk about the class primitive and how that will allow us to actually send changes to this asset, even if it's instance in our scene. However we have it in our scene, it will allow us to actually be able to make changes that will be propagated throughout our entire scene to this asset.